Got it. Lyndon, where did you come from as far as recently in business?
I've been practicing pharmacy for 35 years. The majority of it has been all administrative.
Okay.
So I hardly ever filled a prescription, believe it or not. I was at National Jewish Health as their director of pharmacy. Decided, I don't know, I guess it was like a wake-up call on one of these days that went by back in around December. My little guy kept saying, Daddy, how come you never, pick me up at school? And started kind of looking at my life a little bit more, and I realized, boy, you don't work 5 days a week like you're scheduled. You work 7 days a week, and you're constantly running back and forth, and all that is good if you have a little bit of control over it, but I got zero control over it. So decided to retire from pharmacy and started thinking about what I really like. And one of the things that I've always liked immensely is real estate. So that brought me to you.
All right. Excellent. Lisa, we know about you and the trouble that you cause. We'll wait one more minute here and people may still come on. So do you know much about—
Don't pick on me.
What? Don't
Do
pick on
not
me.
pick on
Yeah, I'll pick on you because you've helped me out, and I'm just trying to get you to understand everything in this business that we can. So
I realize that.
you guys, this class is mainly going to just be about basic construction, because a lot of people have no clue about construction at all. And I think it's important that when you're out showing houses, you have a general idea of what's going on and how a house is built, because you are going to sell some new homes down the road. And when you go to a walkthrough with a new home builder, you want to understand what the house is about. So I don't know, Lyndon, have you been around building or construction at all? Do you know much about it?
Other than giving help to a builder in Florida, when I lived in Florida, about acting as if I was an appraiser at the time, or a home inspector, I should say, more than an appraiser. That's all I know, other than walking around and pointing things out and asking questions about certain things.
Okay, good. I'm going to shut this door. I'll be right back. So let's get started here. I've got numerous videos that I'm going to play, and then I'm also going to stop it, just kind of explain things, talk about things. One of the ones I'll do is talk about framing and the components of framing a house, and just so you get a little bit better idea. Lisa, I think you might have seen some of these. Some of these I don't believe you have because they're new, but can you see the screen okay? Is it coming up fine? And you can leave your mic on, Lyndon, if you want, because it's probably only going to be you, me, and maybe a few others. Lisa, I think, will jump in and out of here if she needs to. But can you hear me and see the screen okay?
I can hear and see everything. It's perfect.
Okay. Perfect. I'm glad it's perfect. So let's start with this. Are you guys familiar at all with over excavating? Okay, and what that means, as you see this big tractor here is pulling. So this is actually of a subdivision here in Colorado. They are over excavating approximately 20 feet down. And as you're going to learn, what they're doing is taking soil out and then bringing different soils or conditioned soils back in and then recompacting the soil before the houses go on top of this. And a lot of times you'll drive by a subdivision and you'll see big mounds of dirt. And then 2 days later, you go by and all that dirt's gone. What they've done is taken that dirt that they've been conditioning, wetting it down, turning it over, and then they put it back in so that they could hopefully get rid of the issues with expansive type soils. There's soils and contracting soils. You have both soils that will expand and you have soils that will contract when they get wet or whatever. So building in Colorado is somewhat unique because we do have quite a few different factors. We can have homes built on slab of granite, and you can have homes that are built in these different areas where there's a lot of clay soils or expansive soils, or a lot of times you might hear the term bentonite. What part of town is your house in, Lyndon?
I'm in Littleton, so
Okay.
we don't have bentonite in every home, but there's some in here that we've heard have gone through it.
If
I
you're
think
in
we all
Littleton,
have it.
yeah.
Yeah, I think
Are
we all
you
have it.
east? Are you east or west of Wadsworth?
I'm on Ken Carroll, west of C470.
Okay, so you are in an area that has potentially a lot of problems,
Correct.
which you have to be careful of. So back in the days when they built a lot of those homes in the 70s or 80s, they didn't do this kind of over excavation. Now they do. With when you see new subdivisions going in, you'll a lot of times see this. So I'm just going to play this and we'll just talk about some things as we go along. So see right here, you can see this is homes over here to the side, and these are going to be new homes where they've over excavated. So you've got a road here, and then you have a road that's going to be on the other side. This is going to be a strip of homes, and they've taken all that soil out, conditioning it, putting it back in, and as they put it back in, about every foot, they're going to recompact the soil to make sure that you don't have those issues.
So this is the thing with Colorado that I was just explaining. The soil is really expansive. It sucks. So if you just grade it normally and build houses on top of it, it's gonna settle and do all sorts of weird stuff, crack foundations, everything's gonna be a mess. So companies like Bemis have to come in here and over excavate. This is where houses are gonna be all the way along here. There's a road right in front of it and a road right out here. They have to over X. This is about 20 feet all the way down. And then run a tractor and disc through it with a water wagon, moisture condition the soil, recompact it, and then the scrapers will pull from a stockpile and pull all the material back in there, and they'll compact it in lifts, 1 foot lifts, all the way back up to where it needs to be.
So that gives you a pretty good idea of all of the work that goes into this just to get the soils in a decent condition. Welcome, Jeff. Thanks for joining. This is something that is ultra important in in areas that need it, and we'll find that a lot of builders are even over excavating all the time. Even if the soils are marginal or in good condition, they'll still tend to try to err on the side of being cautious. And that way they don't have the problems coming back where they need to do something and go back in and fix a whole basement or numerous basements. Or in some areas, we've seen houses that neighborhoods where there's been hundreds of homes unfortunately impacted by all this type of thing.
It's crazy how much earth they have to move out here just to build houses. I've never seen anything like it. This is the only place in the country I've seen over excavation like this consistently throughout the entire city.
Now, he says throughout the entire city. That's not necessarily always true, but you do see it most of the time. And this looks to be out towards, it looks like out by DIA possibly, because we're quite a ways from the front range there. It wouldn't surprise me if this is maybe Commerce City area. Can't tell for sure. But, or up north, because you do have one of these, looks like that's where they're drilling, and they built a wall around it where they try to hide that 200-foot tall tower, which doesn't do much job. But so that kind of is a little bit of an overview of what you're seeing when you go by. This is the soil that they've taken out. This is soil that gets conditioned, and then they, like you said, they bring it back in, they water it down, they compact it, and they do it in basically 1 foot increments and build that soil back up. And then a lot of times, if the soils were pretty bad, they may still build with a structural type basement where it's not they have maybe a distance of 18 inches between the foundation floor and a wood foundation or a floating slab that they put 18 inches above that. Because you can have areas like down in Littleton, up by Flatirons Mall is a horrible area for bad soils. They've had to take and a lot of the exterior part of the mall up there, they've had to make it into taking all the concrete out and putting in all pavers because the soils shift so much that the concrete just breaks. And that area is notoriously bad. And just to the south side of the mall, in that area of Superior, there are some really bad areas where some houses have actually been destroyed. So next, then let's talk about proper backfilling and what is backfilling of a foundation. So here we have a picture basically of the foundation. Now what they're going to do, they have to dig all that out. Now what they have to do is put that dirt back in around there. The black that you see there is waterproofing to help moisture from penetrating from the exterior to the interior of the basement. Not always a basement, sometimes it's a crawl space. A lot of builders are building on crawl spaces because it's cheaper and they can offer a reduced price. In particular, one that I've sold quite a few of their homes is D.R. Horton. And D.R. Horton, I sold 5 homes last year out in Strasbourg. All of those houses are on a crawl space. And I've sold a couple of houses in the Aurora area where they're doing crawl spaces and basements, both. But you're going to find that black tar type material that is going to help water from penetrating into the basement. Now, as they fill the soils, it's really important that they stay away from the edge of the foundation by driving perpendicular or parallel, I should say, parallel to the foundation. They can drive along this area because the soils are separated from the foundation walls. But when they start filling this dirt in here, they have to drive perpendicular up and back and forth to the foundation walls. The reason for that is, just think of it, if you're driving along this way, you're pushing the soil away from the tires and it's going towards the foundation wall and can cause the wall to bend or break. Whereas if you're driving perpendicular up and back and forth to it, the soils are going from side to side and not putting as much pressure up against the wall. And you'll note that when they backfill, they don't drive all the way up to the wall. Typically, they drive up to a portion of it and back and forth. They don't go right up to the edge of it. So we'll just play this for a little bit.
Hey, what are
For the perimeter drain, that part about it was my clean rocks all was about as close as I could get earlier. So I had to track back and forth to get that, but I figured this would work better than trying to bring the loader because the loader is not going to reach. I'm trying to dump off the edge there. So I'll just kind of start down here. They got some blocks down there for piers because there's going to be a porch on this end of it. So I can just basically backfill about up to there. Then they got to stack more blocks and backfill the rest of the way. This is the water line. I'm not 100% sure where it's going to go, but
We don't need to do all that jibber jabber. So as you can see here, he's driving along this area to start taking dirt and put it into this area. And then they'll be getting probably a Bobcat or a front end loader to go back and forth and compact those soils up against there. You'll also see him use those hand compactors that vibrate very hard, and they'll just go around the edges or on the interior as well if they need to.
middle of the pile still. On my every other day schedule, because I'll actually have some videos to.
So it takes
Post
a
if I
lot
have
of
time to
soil
edit it.
and a lot of rock according to how oil conditions are and what they want to put in the base of that foundation area.
$69 US Special
good, we
Forces
have
device
commercial.
turns men into beasts. It emulates 54,000 crunches.
So see, notice he's not pushing very hard up against that wall. Let it play. So now what they're doing, you don't see this all the time, and it can be in different locations, but they stack the so that they're putting pressure kind of like a pier on the outside edge of the foundation wall, and then they're still going to put dirt in there. So those act as kind of an extra support. And then they'll push the dirt out to the side.
And just try to.
Basically fill that whole void up. So
What
that
I'll
they can
do-
start compacting it and pressing it towards the foundation. So here comes Bobcat. And you notice, like I said, he's going to try to approach the foundation perpendicular so that they aren't putting the pressure against the wall as much. There we go.
I got a couple more of those.
So see, now that they've filled that all around, you would notice that from about 10 or 15 feet out, the tracks are going to go towards the foundation. They're not going to drive along this edge. If you're in an area and you see a builder in either their front end loader or their Bobcat, and they're driving parallel to that foundation, you want to question the supervisor what they're doing, because they should not be driving this way at all within 10 feet of that foundation wall. And you can see these are the cinder blocks that they stacked up as an extra support on the outside to help shifting. You don't see that very often here. I've seen it a few times, but I don't know if that's to do with the types of soils or the moisture content or what, but
Bob,
yes.
Get up
He-
and like
he did say something about that's actually for the porch, which I've never seen that. And I've seen a
I've
lot.
never seen that on a porch. Now, what is happening now with a lot of builders? When you look at newer homes, a lot of builders are actually pouring a foundation wall for the front porch that's connected to the foundation itself. And that's a much better way than having, I think, pouring concrete on top of the cinder block, which is still going to have a tendency to sink. So you actually, a lot of the builders are building a foundation wall structure for the front porch or the back porch sometimes to be supported by, which is a much better way. Obviously, it's more expensive, but it's a much better way to construct a home by doing so. Let's see if they have any.
The other thing I saw too, that they're not using any water to backfill too, which is a major no-no, because it's going to roll back in on the foundation later on once the house is
It
established.
can, and I don't know what the moisture content of the soil might be high enough to where they aren't doing that. I don't know. Because yeah, a lot of times here we add some moisture to it to bring it to a certain moisture level in order to compact it. So not sure on this one. I'm sure it's not in Colorado. But that just gives you kind of an overview or a look of what it does kind of look like for a backfill and a compression into it. And then this gentleman is going to talk about the foundations itself. And this kind of gives you an overview of what is a foundation, floor and wall, and how it's constructed, and the reason for things, and also the reason for why we need to make sure they put in. Typically here, they're going to build with a French drain around the entire perimeter of the foundation and collect water that comes up to the foundation and gather it and put it into what they call a sump pit. So here we go.
Here. It's so important to get the foundation for a new home right that we're going to take a deep dive into what quality features are needed to avoid problems. If we get the foundation right, it will last for generations. Get it wrong, and your new home foundation can be an expensive headache for as long as you own the home. So, there are three critical components to a home's foundation, and those are the soil beneath that supports the foundation, the waterproofing and drainage that surrounds the whole foundation, and then lastly, the foundation structure itself. Now, because these three components are so complicated, we're going to cover them in a three-part video series. Today I want to share with you the first part of the series, the foundation structural engineering for a new home with a basement. I will share with you some best practices that will help keep your home's foundation free of structural problems and basement water leaks. The foundation is such a critical element of any home. Not only does it support the entire home and its contents, but it also houses everything in the basement. Things like hot water heaters, furnaces, laundry appliances are expensive items that need to stay dry.
So down here, you notice that the wall looks kind of, it almost looks like brick. Well, that's because the forms they used to pour the concrete into have that look to it itself. That's not something that you typically see, but once in a while you may see it. We have the hot water heater in the foreground. We have the furnace off to the side. And down there at the far end, does anybody know what that is? Lisa, you should know this because
Oh,
I
Bob.
pointed them out to you.
Or is that it could be actually a gas thing, but it looks like a sump pump.
I believe it's a sump pit and pump. Yes. And so he's gonna be talking about a French drain that goes around, and I was talking about that earlier. And it's gonna drain into typically a corner where there's a pit, usually it can be 3 or 4 feet all the way. I've seen them as deep as 10 feet deep. And that it's going to gather and collect water in that. And then if there's enough water for a pump to be installed, you'll do so, and there'll be electrical there, and they hook up a sump pump, and that will eject the water outside, not into the water system itself, but it'll inject it to the outside ground. Sometimes you'll see pipes that are coming out of the basement and run maybe 15, 20 feet. Some just exit maybe 4 or 5 feet. If this exits too close to the foundation, it can cause water to seep back in and be a problem. So you want to make sure that that pipe outside is probably, I'd say, a minimum of 4 feet away. Okay. Whoop.
Here it is, the Vanish holster, the world's most comfortable holster.
We hit the wrong button.
Hi guys,
Bob.
Michael with Armchair Builder.
All right.
Foundation is such a critical element of any home. Not only does it support the entire home and its contents, but it also houses everything in the
we've seen this
basement.
part already.
Things like hot water heaters, furnaces, laundry appliances are expensive items that need to stay dry. On top of that, the foundation is such a massive
want you to keep
drainage
doing
for
that.
home
Sure.
foundations. So let's first take a look.
Hang on, guys.
Hi guys,
I'm
Michael
getting
with
there.
Armchair Builder and basement water leaks. The foundation is such a critical element of any home. Not only things like hot water heaters, furnaces, laundry appliances.
Okay, one thing I wanted to point out right here. This is for a future bathroom, if you so wanted. This would be for the toilet, and this would be for the sink drain or whatever. So in case you see something stubbed out down there, that's probably for a basement bathroom, if and so you want to do that.
Are expensive items that need to stay dry. On top of that, many of us will finish the basement at some point in time, so it's imperative that the foundation does its job. So let's take a look at the engineering behind a quality poured concrete foundation. So here's a quick look at what the foundation looks like after it's been poured. You can see the brick pattern in there, and also the footing sticking out below the wall down there. That's supporting the wall. The brick pattern is because they use those brick forms that have that pattern in them. First start by showing you guys the anatomy of a typical poured foundation concrete wall system here. And this is a cross-sectional view, so if you cut the house in half, this is what it would look like. We start with the footing, which in our case for the open book build was 16 inches wide and 8 inches deep. And then the second pour, that's poured first. Then the wall is set up on top of that, the forms, and we pour that. For our case, we went with a 9-foot tall wall because we're going with a finished basement in the future, and we wanted plenty of headroom to make it feel like the traditional, living space. That wall was 8 inches thick, 9 feet tall, and then later on we come in and pour the basement floor, which actually rests on that little ledge here that's left over, 4 or 5 inches of foundation of footing. And so when anyone quotes you a 9-foot tall basement wall, you have to subtract that 4 inches for the basement floor to get the head height from the top. You're going to be standing on top of this basement floor down there when we're finished.
Now, another thing, you guys, these floors are not hooked, or there's no rebar into the wall. They are independent of the footing and the wall. So that if the soils move somewhat and push on this basement floor, they can move independently a certain amount. Now, obviously, if it moves a foot, you're going to have an issue. If it moves an inch or two, it's made so that it can move independently and hopefully not put any pressure on, if you finish the basement, not put any pressure upstairs into the joists. Okay.
This is the
Hang on, did it
AccuBrush
again.
paint edging system, which you are
Gotta
seeing
quit
in
doing
use
that.
right here. Take a look at how quickly we can edge around this window.
I'm not having very
Hi
good
guys,
luck today,
Michael
guys.
with Armchair here.
There we go.
And this is a cross-sectional view, so if you cut the house in half, 16 inches wide and 8 inches deep. We went with a 9-foot tall wall because we're going with a 8 inches thick, 9 4 or 5 inches of foundation of footing. And so when anyone quotes you a 9-foot tall basement wall, you have to subtract that pump truck to put concrete between the forms there to go ahead and get those filled in, so then we can level it off and then let it set up, remove the forms, and then build the foundation walls on top of that. So we put 3 strands of rebar, seen in this photo here, in the bottom of these footings to give it support along the full length of the footing. So here's a look at it shooting down through the footing forms and kind of what that looks like before we pour. You can see the rebar, 3 strands along the bottom of the footing. The lengths are tied where the ends of the rebar are. See these ridges in the rebar? That grabs onto the concrete. So if they were smooth, they wouldn't hold on as well. So the concrete's going to go around those rebar, and it's going to really latch onto it with those ridges to really give it strength. These chairs are here. That black chair holds the rebar 2 to 3 inches off the ground, which gives it maximum support. And then you can see these nails right here show where the top of the footing needs to be poured to be level. We want to make sure this footing is level because everything above that builds off of it. So if the footing's level, the foundation wall will be level, and then the framing will be level. So really important there. So here's another cross-sectional view of the footing with the 3 strands of rebar in the bottom. So here's a quick look looking from the outside of the foundation at the foundation wall and footing. Now this is a little bit of an exaggeration, but you can see this void created here on the right side under the footing where there's settlement taking place in the ground beneath the footing. And what happens is if there's no rebar in that footing, it wants to settle there. And this settlement can lead to cracking in the footing and the wall above, and eventually potentially a settlement in those where they actually move down, creating a structural problem for this house. So the 3 strands of rebar in the bottom of the footings are a best practice. And this is probably a good time to say that not every crack in the foundation wall is a structural problem. When you want to be concerned from a structural standpoint is if the crack displaces or moves. And this can be in the form of a vertical displacement, as just mentioned with settlement, or it can be in a horizontal displacement. And remember, any kind of displacement in a wall crack can cause a breach in the waterproofing membrane, which can lead to water leaking into your basement, which we obviously do not want. So now let's take a look at the engineering behind the poured concrete foundation wall. We're placing the concrete between the forms here, and once everything's done and we're ready to backfill, our excavation contractor starts to fill in around the foundation. And this starts to put a lot of pressure on that wall. You can see here the arrows indicating the pressure on the outside of the foundation wall, which wants to bow that wall in. So in order to counteract those forces, we put steel rebar in the wall, and these are the vertical rebar every 3 feet along the length of the wall from the footing. We also put horizontal rebar in the wall. It's hard to see here, but they're sticking out, one in the lower third, middle, and top of the wall where they're forming up here. So here's a plan view of the foundation wall, looking at it from the outside, the footing and the wall here. And you can see the vertical rebar every 36 inches along the length of the wall, number 6 rebar. And then we've got these horizontal rebar, one at the top third, one in the middle, and one in the bottom third. And that works like kind of like a belt on a pair of pants holding everything together on this wall so that we really have a solid wall that's going to hold together and counteract those forces from the outside. So one other critical piece to that foundation wall pour is making sure they don't leave any voids in it. So we want it to be one solid mass, so any kind of voids will create a weak spot in the wall. So they're very careful at placing that concrete to make sure that all of the gaps between the forms are full. So another best practice, guys, for foundations is to use a minimum design strength for the concrete of the footings of 2,500 pounds per square inch, and then
And we don't need to know all that, but this is a good example here of, this might be the front porch. So this could be a foundation wall that would support the front porch as you walk into the house. This could be a patio, or it might just be, it's hard to say what this part is because as you can see, there's nothing that goes from the main part of the basement into that area. It looks like it's just a support wall. It could be for part of the house. It's going to have a crawl space under it and not have any foundation, because this definitely has a window over here, and there may be, I don't see another window anywhere. But this gives you a very good view of what a foundation should look like prior to it being backfilled. Oh man, I did it again. I'm gonna give me a non-passing grade for today's class. Gotta wait. Jeff, don't fire me. Okay, go back.
The foundation is
Go
such
to
a
here.
brick protecting it from
Here.
and provides a buffer against expanding soils. Be sure to check out our other 2 videos below on
That's enough of
foundation
this
best
video.
practices.
Because I can't operate it. Anyway, hopefully that gives you guys a little bit better idea of what it looks like. Man, I'm looking at the haunted house here. There we go. Now you can't see me. That gives you a little bit of an idea of what foundation work is like and the importance of really getting a good contractor to do that, because if you get a bad pour, if you don't have a good foundation, the whole house is going to be messed up and it's going to be offset and things are not going to be square. They aren't perfect as it is, but when you get a bad foundation, it can totally throw it off. So the last part here that we'll have is the framing part. And this is going to give you a lot of different names of the part of the framing. And I think it's just important that you understand somewhat how a house is built, because people are going to ask you questions sometimes, and you need to be somewhat understanding of what it does take to build a home. And I'll try to hit the...
Okay, let's get down to foundation level. Before framers show up, masons have either built up brick and block walls or poured concrete foundations. In either case, they give us a level base to build off of. In most houses, the first framing member we install is the mud sill or just the sill. This little known piece provides a stable layer for all the framing above it to rest on. If untreated wood sits on masonry, it can rot because masonry always has a moisture content. So the mud sill is made of treated lumber that isn't prone to rot. So it acts as a buffer between damp masonry and all the dry framing above it. The mud sill runs the entire perimeter of the foundation and is almost always tied down with anchor bolts, which prevent the house from lifting up when strong winds blow. The next layer of framing is typically the joists. Joists create the floor structure of a house.
Okay, so are you guys somewhat familiar with joists and those? So this would be either a ranch style home that's on top of a basement, or it could be a 2-story and they're going to build another level above that. But these are your joists, and these are man-made. These are typically called TJIs for truss. It's a company called Truss Joist. And they're man-made. They have a piece of plywood in the middle. And of course, they're turned vertical like that, which gives them a lot of strength. They're lighter weight. They're quieter than what builders used to use years ago, which was 2x10s typically, or maybe sometimes 2x12s. But these don't tend to creak and make noises like the 2x10 or 12 would. And you'll notice that they run the full length. They may tie on to another one, but that gives them the clear support that they need to span this whole area.
They're long pieces of lumber turned on their edge, which are then supported at various points from below. Joists span open space, acting as sort of a bridge across long distances. They give us something to walk on in the form of floors and something to hold weight above our heads in the form of ceilings. Joists used to be just dimensional lumber, like wide, flat pieces of solid wood. But in recent years, engineered lumber has partially replaced them. I-joists are modified I-beams built out of long pieces of strand board and solid lumber caps or flanges. I-joists are cheap, stable, and very versatile. And they often contain pre-cut knockouts.
They aren't cheap anymore because the price of lumber has gone up so much since COVID. It is just amazing how much more expensive everything is. And it's cheaper than using solid lumber, but it's still a very expensive component and a very important component of the house.
that you can run utilities through, like ducts and wiring. This makes later construction phases both easier and cheaper.
So I don't know if you can see those little kind of holes, but that's so they can run ducting through there. The TJIs are made with the structural integrity so that if you take this piece of wood out and start running ducting through there, it's not going to compromise the structural integrity of the support that it's going to lend to the house. There's also going to be smaller ones that you can tap through for plumbing and or wiring for the electrician. Makes it fairly quick. You don't just drill holes arbitrarily through the wood. You're actually knocking out these preset pieces and putting them in through there so that the structure itself is not compromised.
You still see a lot of dimensional lumber on job sites, especially in outdoor structures like decks. The outermost joist in a floor or deck is often called the rim joist or the band, depending on application. Other joists pair up with it or run into it. Sometimes joists are even supported by another horizontal framing member called girders or beams. Beams tend to be bigger, stronger pieces of lumber that act as a spine.
So most of us have basements here in Colorado, and this is a good example. Now, this basement is obviously not a poured basement. This is with concrete blocks. So you're going to find that in a lot of times older homes in Denver or surrounding areas where they didn't pour foundation walls. They built up with these concrete blocks. This is the beam that he's talking about. And then the joists, of course, go across there and are supported by these beams as needed by the design of the structural engineer for the home.
For joists to sit on. They're sort of like super joists for other framing members. Sometimes joists even run straight into them and are held on with hardware. Girders and beams are sometimes made of dimensional lumber grouped together. Or more commonly, they're made from LVLs, laminated veneer lumber, a type of engineered plywood that is very strong and comes in really long pieces so that they can bridge longer spans. Now, girders and beams also need something to sit on for support. Sometimes they rest on masonry piers, like in a foundation. Other times, they rest on columns or posts. These words, column, post, are sort of catch-all terms for a vertical support. Sometimes they're made of hollow steel, like this one I installed beneath that overspan girder.
So this is pretty common what we see here in Colorado, especially in newer homes, that you'll have a support piece of metal post going up and down.
In a garage.
Once in a
Other
while,
times they're made of.
Once in a while, you'll see them in the basement made out of wood, but usually they're made out of metal in the basement. And then the support beams like this or posts are from wood. You won't typically see steel unless you're going like in a commercial building and you're going taller.
Wood, like the very common porch post. I installed these 6x6s beneath an under-supported deck. And on porches, you'll see wrapped columns holding up the beams that support the roof and ceiling. Sometimes these columns are very decorative, but they're still structural. But altogether, columns and posts transfer loads from a beam or girder down to somewhere lower in the foundation or another support. Alright, so with all that structure in place, we can move up from the lowest parts of the house. After the joists have created the floor structure, they get covered with subfloor. Subfloor is sheets of plywood or strand board with tongue and groove edges. Pieces sort of interlock to create a stable surface on top of the joists, and this covers the full perimeter of the floor plan, right out to the edge of the structure. Everything above this point sits on the subfloor, and that includes the walls themselves. As everyone knows, framed walls are built with studs. This word is, of course, an endless source of amusement. But stud is really just a blanket term for pieces of lumber stood up on their ends to create the vertical structure of our homes. They're most often in the 2x4 or 2x6 dimensions. Studs can stand individually, spaced out either 16 or 24 inches center to center, or they can.
So this is a good question. If you're selling a new home, the builder will usually tell you, because they're proud of the fact that the exterior walls are a 2x6 construction. So not only is that a better material for the structure and integrity of holding up the walls, especially in a windy area, but it also gives you a better source for thicker thermal insulation. So the home can be protected better and have a higher R rating to keep the house warm or cooler in the different weathers. you'll see this is a man-made type of beam, and he'll talk about this, but these are just 2x, I think it's 2x6s, I can't tell for sure, just nailed together to be one solid piece.
Can be fastened together in groups known as stud packs.
There you
These
go.
packs sort of act as makeshift columns in our walls. They carry heavy point loads from somewhere above and transfer that weight down to a safe point below. But studs never actually touch the subfloor. Instead, they sit on another horizontal piece of wood known as a plate. A plate is basically just a stud laid down on its back. It's virtually identical to a mud sill, except that it's not treated because it's not in contact with wet masonry. This is just kiln-dried 2x4 or 2x6. So you have a bottom plate beneath the wall, and you have top plates at the top of the wall. Top plates are typically doubled up for strength. We call them double plates. Adding top and bottom plates to vertical studs lets us build our walls laying down and then stand them up into place. It turns the whole wall into a rigid unit that acts as one piece. Studs and plates are virtually continuous in a wall, except where they're interrupted by doors and windows. These openings get special framing, and that framing has a complex system of names and functions. For instance, you've probably seen these pieces.
You know what these are called here? Okay, now just think of it. You have a window that's going to go here. And so you don't have the support of every 16 inches on center or every 24 inches on center of having a stud there. So these are headers which take the weight that's above and distribute it out to the side so that they can have a window or a doorway. So you're going to have a header above any window or door in a building that needs that support to transfer that load.
Pieces of solid wood facing outward above an opening. These pieces are called headers, and they're very important. Doors and windows create hollow space in a wall, which means that studs aren't there to support weight from above. So the headers transfer the weight that would be in that space out to the edges of the opening. Really, they act the same way that a beam or girder does to carry weight over a span. They're like a bridge that creates a safe hollow space for the door or window to sit inside. Sometimes headers are also made up of LVLs over longer spans, like garage doors where they need to bear more weight. The ends of the header sit on pieces called trimmer studs or jack studs. Then they're enclosed by taller pieces called king studs, which extend all the way up to the plate. Empty spaces above a door or below a window are then filled with what are known as cripple studs, just little short pieces that provide support and create nailing surface for drywall and cladding. The bottom horizontal piece in the window opening is called a rough sill, and the entire framed opening of a door or window is known as the rough opening. Again, all this structure bears the weight around these openings so that doors and windows don't have to. There should essentially never be any weight on a door or window. They just sit in a hollow opening and do their job. You'll also see little horizontal sections of wood in framed walls. These pieces are known as blocking, or in some countries, nogging. Blocking serves many different purposes. In tall walls, it prevents studs from bowing or twisting. In some cases, it provides a fire block, which prevents fire from traveling up the stud bay like a flue. This slows the fire down so it can't leap between floors. And in places like bathrooms and kitchens, blocking is installed turned up on its edge.
So I'm going to stop that and try to back it up just a touch.
This slows the fire down so it can't leap between floors. And in places like
there are some builders that are fairly large name that I don't agree with the way they do construction, and sometimes they try to get away with things that the inspectors don't care, or they get paid off. But there are numerous builders out there that try to do shortcuts with their framing and don't put in those blocks in between, which are an important part to help, as he showed, stop that fire from spreading.
Which prevents fire from traveling up the stud bay like a flue. This slows the fire down so
and I'm not going to talk about builders or the lack thereof of quality with some of these builders, but there are 3 or 4 builders that I do not sell their homes. Just because I have seen some of their practices, and I've talked to people who have worked with them, and they do shortcuts. They just don't make a quality home. If you ever want to talk about that with me personally, that's great, but I don't want to spread that out in the classroom, and I don't want somebody to go to a friend who works for one of these builders and say, hey, my managing broker says that you guys are trash and I'm not going to sell your house. It's unfortunate that there is that, but before you just run out and sell any home, you want to do some background check and on builders and talk to other agents and talk to people who have sold homes to make sure that they stand behind their product and that they do a good job.
So it can't leak between floors. And in places like bathrooms and kitchens, blocking is installed turned up on its edge. This provides solid wood to mount towel racks, cabinets, and other fixtures to. You really see various types of blocking all throughout a house. That covers much of what you'll see in a single bottom floor. So, moving up, we come to staircases. Stairs used to be built entirely from notched lumber known as stringers. In some cases, especially outdoors, they still are built this way. But many modern interior staircases are built in factories as single enclosed units. These units are ordered beforehand based on accurate measurements and pretty much just get installed like a ramp. The vertical pieces of staircases are called risers, and the horizontal pieces are called treads. They may be attached to frame walls at either side for extra support, or rest on smaller frame knee walls beneath them. Knee walls are just short wall sections, typically under 3 feet. Sometimes they support something, other times they're freestanding. I'll mention here that the word header is also used to describe a piece of framing that opens up a hole in a floor or ceiling. Just like a small girder, a ceiling header carries the weight of several joists by transferring their load out to other parallel joists. This lets you create openings for pull-down attic stairs, dormers, staircases, you name it. So that's a second definition for headers, and it serves a slightly different function. These headers are installed in horizontal floors as opposed to vertical walls. Okay, continuing upward. Higher floors in a house are built much like the first floor. Joists sit on the top plate of the wall below. Subfloor covers those joists, and the next frame wall sits directly on that subfloor. It's pretty much exactly the same floor to floor. Taller houses may require more beefed up framing, especially on the bottom floor. But terminology-wise, words are going to have the same meaning everywhere. Things only get different again when you finally get to the roof. Roof framing is a complex topic because things stop moving in 2 dimensions and they start converging in 3 dimensions. In traditional framing, roofs are made up of rafters. Rafters are a lot like floor joists, except they're set diagonally at a fixed pitch. At the bottom, rafters sometimes sit on the top plate of the wall below. Other times they sit on yet another floor structure in the attic. Rafters typically travel upward and converge at a ridge board. This is a fairly tall board that gets sandwiched between rafter peaks. In houses with gables, the ridge board runs all the way out to the exterior wall and sometimes beyond. In houses with contoured roofs, the framing gets more complicated. To create an outside corner, a hip rafter descends from the ridge to the corner of a wall. To create an inside corner, a valley rafter does the same thing. So these roof contours are simply called hips and valleys. Shorter rafters that meet a hip or valley are called jack rafters. But rafters that go all the way to the ridge are called common rafters. On gable roofs with an overhang or an eaves, the suspended rafter hanging out in the open air is called the barge rafter. Down at the lower point, the projecting end of the rafter is called a rafter tail. These are usually tied together with a subfascia. And in houses that will have an enclosed soffit, the little backstrap piece of framing is sometimes called the lookout. Now that's a traditional roof.
Now, most of those terms you don't need to even worry about. And most houses nowadays are not built with rafters. They are built with trusses that are prefabricated, brought into the construction area and already have been constructed by a company. And they are engineered in such a way that they know that they can take on a snow load that we have here. So we have, because we do have snow and because of that weight, that is a very important part of the construction of a home. The other thing is that some people may say to you, hey, we're thinking about getting a tiled roof put on our house. What do you think? Well, the first thing you would want to say to those people is you better get a structural engineer to let you know what kind of, there may be some things that you have to do to the current roofing or the truss system to support that extra weight, because a lot of times that roofing that's like a concrete block, I'm selling a house right now that has, they weigh about 11 pounds a piece. Well, you take 11 pounds times hundreds of them up on a rooftop, that structure, those trusses have to be engineered in such a way that they can support that, plus the weight of a snow load. You can't just put on these heavier type tiled roofing on a standard roof that was not designed for that. So that's just a little common knowledge there to let your people know if they mention that to you.
But many newer homes and smaller commercial buildings aren't necessarily built this way anymore. Instead, they're built with something called roof trusses. A roof truss is an engineered, pre-assembled unit that creates the shape and structure of a roof. In truss roofs, multiple trusses are installed side by side, like rafters, and braced together until the roof sheathing can go on.
Let me back that picture up just a little bit.
Rafters and braced together.
So this is basically if a house had like a vaulted ceiling, you can see this is the bottom part of the truss and it's at a slight angle. This is the webbing coming down that is going to support the weight of the roof and also the snow. And so these are clamps that get pressed on with a hydraulic clamp. I used to build roof trusses over in Grand Junction. And it's a very complex way. These clamps cannot just be put on in however you decide to put them on. They have to be so many inches up and over, and it's quite a neat thing to see done. Also, they have certain sizes of these, and when you're getting a home inspection, the inspector is going to crawl up in your attic and check the roof trusses or the rafters to make sure that they are done correctly and that you don't have broken trusses because maybe there was incorrect design or whatever. I sold a house many years ago that when the inspector went up in there, almost every web member that went off at an angle was cracked on every single truss, which obviously meant that the engineering was not correct or the application of installation was incorrect or both.
Until the roof sheathing can go on. Trusses are really kind of miraculous. They're made of much skinnier, shorter pieces of lumber pinned together with spiky metal plates. Altogether, they create sort of a web, and that web is very strong. In fact, it's so strong that most truss roofs don't even need load-bearing walls beneath them. They act like a big girder spanning from one outer wall to another. Trusses are also sometimes used for floor systems. They're very strong, they speed up construction, and they cut down on the amount of large dimensional lumber that we used to need to build houses. So you've got traditional roofs with rafters, or you've got trusses. Kind of two different worlds. But after all this framing is in place, our structure is essentially created. And yet, it's still not stable. Both the walls and the roof will still need to get sheeted or sheathed. Sheathing is a layer of plywood or strand board that covers the entire framing system from the outside like a skin. It's the layer beneath the house wrap and the siding. Sheathing is very important, and it often does more than just close the house in. It also prevents the house from falling over. But that's a topic for another time because it's complicated and it deserves at least one video of its own. This video is about framing, and
So I hope that gives you guys a little bit of an overview if you're not familiar with construction. And it's a good idea to just go out too and see if you can meet with a builder, have them take you through some houses, or if you know anybody who's having a house built, go out with them and take a look at it. Or maybe get a hold of an inspector, see if you can be part of an inspection, because some inspectors do pre-home, or I should say, they do construction inspections while the home is being constructed, just to help give the buyer a peace of mind. Any questions that you guys might have on these videos or anything else that's come up with your real estate?
It seems like to me, Bob, it seems like to me, it used to be, at least in my case, a fear of buying a brand new home because, you know, you just didn't know if the foundation was done right. So you always wanted to buy a traditional home that's been there for a while because you can pretty much get an inspector and see if the structure's really well. But in certain cases, outside of some of those builders that you didn't mention, it seems like they're building homes probably better now than what they used to.
They are. They're building them stronger with less material. They're building them with a much closer tolerance for allowing air into the house. And they're also making them much better as far as the amount of insulation that's in them. And they're much more efficient for heat and cold And your heating bills go down, you have more efficient furnaces than you used to have, more efficient water heaters. So yes, overall, it's typically going to be a much more sound home than you buying a 1950s home. But you'll also find too that a lot of the older homes, like the old Promax in North Glen and other areas, they built a very good home for what they did back in the 50s. A lot of their concrete was done without expansion joints in the concrete itself, and the floors are perfect. 60 years later. So, but yes, overall, the house is going to be a much tighter, much more livable, much more efficient home to live in. Absolutely. Jeff, you have anything you want to add or ask, or Lisa, anybody? I hope you found this helpful. I'm going to do basically the same thing this coming Saturday. If you're thinking about joining, I like to try to do the same basics class for the first Wednesday and the first Saturday of the month on the Snow Before You Go. But don't hesitate if you have any questions or comments that you want to talk about on anything, showing homes, whatever. Give me a call anytime. I know, Jeff, you have my number. Lisa, I believe you have my number. Lyndon, if you want my number, I'll be glad to give it to you right now.
Yeah, let me take it.
Sure.
Write it down. Okay.
It's 303
Mm-hmm.
898 8638.
Okay, got it.
And I'm typically in the office every morning at 5:30. And that's Monday through Saturday. I try to take Sundays off, but that doesn't always happen. But if I see you guys call, and I'll always try to answer, or if I don't answer, I will call you back. Okay.
Thanks, Bob.
Thank you
Bob.
all. Thank you. We'll see you. Take care, you guys.
You too.
Thanks.
You've just heard about many, if
Yeah, we're